Previously on Retro Hack Shack. So the other day, I was visiting a local e-waste facility when I saw what I thought was an interesting PC desktop. But when I took a closer look, it turned out to be an Amiga 2000. This card in particular supports a 68060 processor. And look at the CPU. Oh no. These things, I swear, the death knell of so many systems. Still getting 6 volts on the 5-volt line. Now I'm getting 7 volts on the 12-volt line. What is going on? So here's the power supply. The first thing I notice is it's super dirty. The second thing I notice is that at least this cap here is bulging a little bit. It hasn't popped open, but it's bulging a little bit. And you see how close it is to these, I don't know, these coils shouldn't generate too much heat. You would think that all the heat would be in here. I'll have to pull out this whole board, and then I can take these caps out and test them and probably replace them anyway. Okay, so I took this and sprayed it off with my, blew it off with my compressor with some air. And yeah, you can tell right away. We often talk about caps that are leaking, or caps if they're vented at the top like these are that are bulging, right, as signs of bad caps. But also a bumpy cap is a really telltale sign that a cap has gone bad. This cap is fairly smooth to the touch, and I don't think it's going to come across very well on camera. Maybe it will, but this is lumpy and bumpy. It's really kind of mottled under here, and it's easy to see with the naked eye once you get the dust off. The dust was preventing me to see that earlier. But I can guarantee you that this cap is completely dead. I mean, it's just cremated, right? And it's to the degree that it's really, really bumpy like this. So anyway, that cap for sure has to go. The power supply is not going to work correctly with a cap like that in there, or very unlikely to work correctly, I should say. These other caps over here, the big ones, well, I guess I can just move the camera. These big caps over here are going to be fine. Well, most likely they're going to be fine. I shouldn't say that for 100% certainty, but these big filter caps on the primary side are most likely fine. Okay, so I pulled out all the caps out of the low power side of the board, which wasn't easy because they were all in there with hot snot and everything. And here's that cap that was the one that has all the bumps and stuff on it. And you can see the lead on this side just pulled right out, or was maybe even disconnected when I desoldered it. It just came right out. So this may not have even had a good connection. That's how bad this one was. So that's going right in the trash. But all the other caps actually test good. I can show you on this one. There we go. And it says it's a good cap with low ESR, and they all test that way. So I think I would have had to order more of these because I don't have any on hand. I think I'm just going to put these back in, and then I found another one. They're all 40, well, most of them are 47 microfarad at either 10 or 16 volts. This one's rated a little higher voltage, which is fine. Yeah, same thing. Good cap with low ESR. So these all test good. So I'm going to put them back in and put this one in place of that bad one and see what we get. Hello, kitty. Hello, kitty. It's the Sunshine Cam. Sunshine does not want to be in the video. She wants to get out of here. See you later, Sunshine. Okay, on with the show. So, yeah, I've spent all afternoon on the power supply. Well, I guess all morning too, really, almost the entire day, if you include changing out the caps or testing the caps. Tested all the power regulators, all the transistors. There's some Schottky diodes here that are limiting the power. Tested those. I tested the diodes. I tested the resistors. There's something wrong with it. I cannot figure out what it is. So instead of spinning my wheels here on this thing until I finally figure out what the problem is, I'm going to do something else, which is I'm going to take an ATX power supply. This is one that I happen to have laying around that I was using for another project. You can see I've already cut off some of the power leads here. So what I'm going to do is I'm going to take this power supply out of this case and mount it inside the original case that went with the Amiga 2000, I think I can probably replace this fan in the process too, put a quieter fan in, and I'm going to hook all of these wires up to the appropriate places inside. Now also Amiga Kit makes an adapter that you can put on the end of one of these ATX power supplies that will, it'll go from here to this. But the problem is that creates extra bulk inside the case. And I don't really want to do that, and I don't want to take the time to do it. I want to get this episode done sooner rather than later. So I'm going to go ahead and spend this evening changing out all of these wires, making sure that they're in the right place. I've already tested this supply so that I do know it works and all of the rails are working. So yeah, that's what I'm going to do. I'm going to keep the look of this, make sure that it fits in the case, but on the inside it'll really be an ATX PC power supply. The important thing to know when you're doing this is you need a power supply that has the right rails. And what I mean by that is the Amiga 2000 requires, I think all Amigas require plus 5 volts, plus 12 volts, minus 12 volts, minus 5 volts. And as you can see on this power supply, this does have all the right rails, and it does say what the different colors, the different wires. So I don't even have to turn it on and figure it out, although I have done that. But you don't even have to do that because they're all labeled here and it tells you how many amps are supplied on those lines. So this power supply should work just fine for this Amiga 2000. In an upcoming episode, I'll be showing some really cool mods for the Amiga 2000, including some that I designed and were produced by PCBWay. PCBWay offers inexpensive PCB manufacturing and a whole lot more. Need assembly services? No problem. They can do front side, back side, through-hole components, you name it. They also offer 3D printing, CNC milling, and more. So check out PCBWay for your next project, and I thank them for their support of the Retro Hack Shack. Okay, well, if you've never seen the inside of one of these power supplies before, all of the various colored wires, which represent different voltages, are soldered to the board in groups. So this would have been, let's see, this was yellow, so that would have been 5 volts on the Amiga power supply. Normally 5 volts is red on a PC power supply. Blue is ground where normally black is ground. Anyway, you can see how those are grouped together. So what I did was I just cut those off, cut all the wires off from this power supply, and voila. This is an ATX power supply. And what I did was I desoldered all of the wires that went into this. It's a real pain in the butt. I mean, there are other people, what they've done is they've cut the wires off here and put the two wires of the different cable harnesses together and then put heat shrink over them. What I did was I went ahead and cleaned up the whole board and wired all this stuff directly to the ATX power supply, and hopefully this is going to be long enough to reach the where it plugs in on the Amiga. Now, I'm almost done, and I'm going to show you a little bit more about this in a second, but I was testing this out, and it's just one of those best practices. Before I turned this on to do any further testing, plugged in any mains or anything like that, I just went ahead and decided to test to make sure nothing was shorted. And sure enough, I found that ground and 5 volts were shorted together. That would have blown something up if I were to plug this in and turn it on. The real problem was just a little bit of a bridge that I had between the ground and the 5 volt cluster. There was just one little wire that was going across there, and I was able to find that and fix it. Let me just give you a quick tour of this power supply. As you can see, this ATX power supply is quite a bit smaller than the Amiga one that was in there before. One of the issues I had, besides soldering on all of these wires in tight clusters down here, which was a real pain in the butt, not for the beginner. In addition to that, when I went to pull out the plug, there was this coil, some sort of a choke on this where the power plugged in here. So I had to, the only way for me to get this working was to desolder this out of the old case. I had to desolder this. Luckily the mains aren't connected right now. I had to desolder this take this board off and then move this over to this case and then put it back on. Otherwise, it was just a matter of connecting everything back up, connecting the ground back up. One interesting thing, I'm not sure exactly what to do with it, is the original power supply was 110 only. This power supply has a switch to go from 110 to 240, or 230, I don't know. But anyway, yeah, I don't know what to do with this, really. I might cut a hole so that this is accessible, but as it stands right now, there's no cutout for a little switch like that, so I'm just going to leave it there for now. And here's the old ATX power supply, and the nice thing is I've got plenty of nice thick power wire to use now. I'll put that in a box or something so that I can come back if I ever need a little bit of scrap wire to carry some decent amount of voltage. This will be perfect for that. All right, time to test the new power supply. You'll notice that there's several wires here that I have taped off, and that is because I didn't need those wires and I didn't want them just dangling out in the breeze here. At least I don't think I need them, so I've left them on for now. Once I've confirmed that everything's working without these wires attached, these are just extra ATX. They're for different things that aren't really needed by the Amiga. So once I know that the power supply is working, then I can go in and desolder those wires or snip them off completely. Now, you also may notice this green wire up here. ATX power supplies have a switch built in that goes to the motherboard and then leads usually up to a button on the front of the computer. That needs to be connected in order for the power supply to work, and it needs to be connected to ground. In this case, the Amiga just has a power on or power off switch, so I just went ahead and permanently connected that wire to ground so that it would always be there and I could operate the Amiga simply with that power supply switch. Now, there's also one more wire that's coming from the Amiga, and this is connected down here to the main connector that goes into the Amiga, and it's called the TIC. And I don't know a whole lot about it, but I know that on the original Amiga power supply, it was sending a signal, either a 60 hertz or 50 hertz. It's kind of a clock signal back to the Amiga. And ATX power supplies, PC power supplies, don't have that functionality. So what I'm going to do is there's a jumper on the Amiga that I can set to pull that clock signal from VSync on a monitor instead of from the power supply. So that's what I'm going to do. And so basically I don't need this anymore. At least I don't think I do. I left it here for now just in case with some of the mods and things that I'm planning, I might want to go back and reattach do a little mod here and reattach a normal TIC signal for the Amiga. I am going to be careful because, like I said, there's exposed mains here. Oh, okay. Actually, I forgot to plug in the cable that goes to the main cable that goes to the board. I had to extend this with some wires because it wasn't quite long enough in this configuration. It goes like that. And in case you're wondering, I'm using plastic feet here that usually would go in a motherboard because there's no holes that match up. I've just got one screw in for now, and then I'm using plastic feet to make sure that this doesn't ground out or hit the case here and short anything out. So that should be good, but I may have to come back later and either epoxy something in or make sure that this board is really secure so that I don't worry about it shorting out in the future. Here we go. I'm plugged into 12 volts. Let's see what happens. Oh, fan is on. I'm getting 11.75 volts on the 12 volt line. Awesome. I don't see any smoke. After the video with the TVs, all the smoke and sparks, I'm just even more careful. Okay, I'm going to check out the 5 volt line here. Perfect. 5.2, it's a little high, but that should be okay once there's some load on it. So yeah, this is looking really, really good. Let's test the other lines. There should be -5 and -12 over here. Oh, -5 spot on. And -12 is the red one in this case. -11.79. this is perfect. Now this is a little bit older power supply, so who knows how long this will last. But as of right now, this is running perfectly. And this one single fan that I have back here, I can already tell is going to be a heck of a lot quieter than the fan that was originally powering up on the Amiga power supply, wherever that went. It's over there somewhere. So yay. All right. Power supply rebuilt.
Gentlemen, we can rebuild him. We have the technology.
Let's hope it works when I plug it actually into the Amiga. One more side note, I think the original power supply for the Amiga 2000, I think the actual draw was only around like 40 or 50 watts for the Amiga 2000. I'll have to go back and double check that number, but I think it was 40 watts or 50 watts. And this ATX power supply is actually rated at 400 watts. So it's 10 times more than the original power supply. So way overkill, but it's designed to work with high loads. It should last for a number of years to come. So I decided I did want to make a hole for that 110-220 switch, and that means it's time to get out the drill. So I started by drilling a hole that was just slightly larger than I needed for the switch. And then, because this is sheet metal, I could use this nibbler. If you're not familiar with these, they really are exactly what the name implies. They nibble out a small amount of metal every time you pull the handle. And you can see here what I'm talking about. There's just these, it just nibbles out a little bit, about a couple millimeters at a time as you squeeze that handle. There were mounting holes in the switch, and so I was able to measure those with my caliper and then transfer those over to where the hole is so that everything would line up properly, hopefully. Then I drilled those holes, being careful to stay on my mark, and then just screwed in the switch, and it lined up perfectly. A little test with the screwdriver shows that it's working just fine. All right, well, I've put a nice new machine-turned socket in here. And a brand new Motorola 68000 P8 is what is in here right now. I believe that's the correct one for this machine. Everything's oriented correctly. So let's just go ahead and turn this on. Actually, make sure that's pressed down. You never know. Oh, gotta plug it in first, I guess. Okay, fingers crossed. Let's see what happens. Got a video signal.
Survey set.
Okay, still nothing. So I'm going to reseat some of these other chips here. Just make sure there's nothing going on there, and we'll try again. Okay, I've reseated the chips, so let's see what happens now.
Survey set.
So I just pulled this chip memory out, and I got my hand up here to get the camera to focus, but I don't know if you can see there's some corrosion there on those pins. I'm not sure if that's from I don't think that's from the Varda battery. I think that's just corrosion over time, normal corrosion. So I'm going to clean these chips off and see if that helps any. Okay, well, that didn't work either. So, something's not right. Okay, so I broke out the oscilloscope just to do some testing here. And hopefully you can see this over here. If not, I can add this in when I do my editing, because I'm capturing the screen. But yeah, so here is the VCC. So VCC is 5 volts, and it's coming in at 5 volts here. The next pin is clock, and the clock is coming in at 7.16 or so. It's bouncing around just a little bit, at least in this software. This isn't the best oscilloscope, but that's where the clock is. And then the next pin is ground, and of course that's ground. The next pin is halt, and I believe halt should be high and halt is low. So I think that's the main issue I have right now. And then the reset is high, and it should be high. And if you turn this off, if I turn this off, wait a second, when I turn it back on, that should stay low and then go high for a reset. And it does, it stays low and then goes high. But if I look at halt, let me turn it back off again and back on. So halt just stays low the whole time, and I believe that should be high, like I said. So that's where I'm at. I need to figure out why this is in halt. If I look at any of the data lines, like these data lines here, they're all just being held high. And if I look at the address lines, it's like they're floating or something. I mean, they're at 1 volt. So all the address lines are the same. There's no data going on, nothing really to speak of. So the CPU, I think in this case, I think it's probably working, but it's just halting. And that's what I need to figure out why that is. Okay, so there's a couple of reasons why that halt line could be asserted low. One is if there's too many bus errors, that could be a problem. That's kind of what I'm leaning towards, but also the Gary chip up here can assert low. So basically the CPU can halt itself if there's too many bus errors. Gary can halt the CPU if whatever it decides to. I don't know why. I'm still learning. Also, the halt is on the Zorro buses, the Zorro slots over here. So if there was a short, like if a paper clip fell in there or corrosion or whatever, it could be shorting the that halt line. Now I measured the resistance here on the halt line to both ground and to 5 volts. Interestingly, it's almost the exact same. It's about 4.7 K. So there's pull-up resistors there. It's not shorted, so that's the answer to that question. But it's interesting that those resistors would be equal values. You would think one would be bigger than the other, biasing it in one direction or whichever direction is not asserting. So I guess it would be biased high. It would be pulled high. So here's where I'm at. Here's what I want to do. I've pulled up the leg over here. That's the halt pin on the Gary chip, because sometimes these Gary chips can go bad. So I've lifted Gary's leg so he can relieve himself, so to speak. You take that analogy wherever you want. And I'm going to see if the halt line here is high or low when this boots up. And at least I'll know whether Gary is an issue or whether the CPU itself is causing itself to halt because of a bus error, probably. Okay, I think I've got my probe on the halt pin, so I'm just going to turn it on and see what happens. Okay, it's definitely on, and halt is still low. So, yeah, it's not Gary doing the deed here. It's probably the CPU doing its own deed on itself. Again, strange analogy. Okay, folks, super close-up time here for the PCB. I think I may have found it. This may not be the only problem, but I found a problem. Every time I find a problem, I'm hopeful that that is going to fix it. So I've been probing around the board and concentrating my attention on the area over here by the processor where the corrosion has leaked up enough to possibly cause problems with traces. And I found this trace here. Hopefully it's clear when I'm this zoomed in. But let me tell you, when you're just sitting above the board at a normal length, it's hard to see this trace right here, especially with this capacitor in the way. So this trace here, when I started to look a little bit closer, was all dark and corroded. And that got me thinking that that could be a problem. Basically, I was just shooting in the dark, looking at all of the traces that are corroded to see if I have conductivity. So if I follow that trace over, it ends up over here at this via. Now, I just have to break in here as I'm editing because I can see now on my big, huge screen in front of me that this is actually inaccurate. I wanted to leave this little bit in because this is what happens. You make mistakes as you go along in your troubleshooting, but you can clearly see that this trace actually is not connected the way that I thought it was. And so that ended up leading me down the wrong path, but I eventually figured it out later. In the meantime, I went ahead and added a bodge wire where I thought the connection should go. So I'm always hopeful when I find a problem like this. It's like, oh, this is going to be it. This is it. This is going to fix it. And of course, there's a million other things that could go wrong on this board, especially with the corrosion. I mean, I did test these resistor packs down here and they're fine. because there was a lot of corrosion there. They seem to be okay. But I'm always hopeful, and it kind of reminds me of what was that? The Wide World of Sports or whatever, where every Sunday I loved watching that just for the opening of the show, where it was like, the thrill of victory, the agony of defeat.
Spanning the globe to bring you the constant variety of sport, the thrill of victory, and the agony of defeat.
So the question is, will this be a thrill of victory moment or an agony of defeat moment?
A few moments later.
Well, it's an agony of defeat moment for me. When I was testing the connection, I realized I had made a mistake on the schematic, and I was looking at A7 on this chip, but A7 is the name of this pin on this chip, not where it's going. So yeah, this pin is going over here to whatever this is, D something or other. So yep, that works just fine, no problem. Dang it, thought I had it. Hey look, it's working! No, it's not. It's not working. Sorry, I just had to do that. So now I can't find anything wrong with the other board still. So what I did was I pulled out this Amiga 500 that I've had sitting in a case for a while, waiting to do a video on it. And I'm going to test the chips just to make sure that the chips are all working. And when I opened this up, I've never been in it before. When I opened it up, look, it's another mod, some sort of chip mod or something. I don't know. I'll have to look that one up. I'll do another video on this, but this one was working, so it wasn't as interesting because I couldn't fix it. Anyway, what I'm going to do is I'm going to just test, I really want to test this original CPU, for example, that was in the other one, see if it works in this machine, test the Kickstart, test the Gary especially. So I'm going to test all the chips from the other Amiga 2000 in the Amiga 500. They're very similar architectures. The only difference is that, there are some physical differences. The power is external versus internal. The keyboard, of course, doesn't attach to the front. It's built into the case. So yeah, very similar boards. In fact, a lot of the references you'll find will, like for mods and stuff, will say, oh, this works on a 500/2000, because they're so similar. So, with that in mind, let's see if some of these chips will work. And when testing something like this is a huge advantage to have a working system, because what I can do is I can pull the chips one at a time from the bad machine, right? Something's going wrong with it. And I can put them over here in the good machine. I've seen people go the other way around, like, oh, I want to see if this, chip works here. This Fat Agnes, does it work? I'm going to pull it, a good one out of here and put it into the bad board. And that's the wrong way to do it. You should always go the other way around, because you could have multiple faults on that board or computer that's not working. You should always take the suspect bad chip from the bad board and put it into a known good working system where everything else is working. That way you're eliminating false positives. Anyway, now that I've got that out of my system, let's turn this off and just start testing these chips to see if they work. Okay, first up we have the crusty CPU with all that corrosion left over on the outside. This was the original one from the Amiga 2000. Will it work? And yes, it does. It works fine. That original CPU is not bad at all. So the connection certainly could have been bad, so I'm glad I took it out, replaced the socket and all that. The CPU itself is just fine. Next up, we have our friend Gary here. Let's see if Gary works. Looking good. Gary does indeed work. So he gets a silver check mark. Good job, Gary. All right, next up we have the Kickstart ROM, everybody's favorite. Now this is I did confirm that this is 3.1, so we should see 3.1 come up instead of 1.3. Hello. Whoa, okay. That may be our culprit. the kickstart ROM might be bad. So the kickstart is definitely suspect. Okay, here we go. Everything is the same on this board except for the kickstart is 1.3. Let's see what happens. Oh! Nothing.
And the agony of defeat.
At this point, I also went ahead and tested all of the other similar ICs, the major ICs on the board, the Denise, the Paula, the Fat Agnes, and they were all just fine.
Several days later.
Okay, time for another update on progress so far. So what I've done is I've actually went ahead and recapped the board. Now, I think that there's a 99.5% chance that this will not affect anything in whether this computer works or not. The reason I did it was because I did want to at least test the capacitors. And so to do that, to do a really good job, you need to pull the capacitors out of circuit because that can be a little misleading. And you need to test them with an ESR meter like this one to know whether they're really working or not. Obviously, if you see a short or a wide open connection, that may give you an indication with your multimeter, but you really need an ESR meter like this to tell you if the capacitor is still good or not. So, so I wanted to use this. I wanted to pull all the caps out, and I figured, you know what? If I'm going to pull them out anyway to test them, and I have the capacitors to replace them, why not just go ahead and take advantage of the opportunity and do it now? So that's what I did. So I've replaced all the capacitors on board. And let's just fire this up. Like I said, I don't think it'll make any difference at all, but let's go ahead and fire it up. And we get the same result. Black screen or gray screen in this case. And yeah, that's it. Nothing working. Now, the other thing that I've been spending my time doing is looking for shorts and making sure there's continuity where there's supposed to be continuity. In other words, things are connected to where they're supposed to be connected. So I did trace out, I don't know if I said this before, but I traced out all of the connections between the ROM and the CPU. That will test all the data lines, at least between these 2 points, and all of the address lines. So checking for both of those between these two, and they were all fine. The next thing I wanted to do was test for shorts, because there could be a short somewhere on the board between one connection or another where there should not be a connection. And so to do that, the process is fairly simple. What you need is a multimeter like this that has fairly fast latching. Let me put this in continuity mode. So when I say fast latching, I mean when you go into continuity mode, you want this thing to sing basically as soon as you touch something that's connected together. So for example, you know, if I put my one probe on ground over here and touch ground over here, I want to know about it as soon as I touch the two things together. So the way that I did this was I started on the ROM chip because that has all the data and address lines. But I said, you know what? I'll do it on the CPU as well. Start with pin 1, and then you can run the other probe along. You don't want to go too fast, but you can go fairly fast and run along the top of all of these pins. No beeping, so I can go on to the next one. And I can start here, and I can run across the top, run across the other side, listening for any beeps that may come up. And I did that. I basically moved along and did that for all the pins. And I didn't find any shorts where there shouldn't be shorts. For example, there's power on one side of the board, or VCC, and there's also VCC on the other side of the board. And so when you hit, you know, those pins, those obviously should be connected together, and they are. Then I thought, okay, well, I'll take the same approach, and I want to check. I don't know why I thought this. This was totally random, but I thought, you know what? I want to check, because those wires, those bodge wires that I have running from here, because these traces were broken, all the way up to Gary up here, I know that those are connected correctly, but I wonder if anything else is shorted because of those bodge wires maybe hitting a sharp pin or something. So I started doing this exact same methodology. I started with one pin, the one pin that I was working on and went down both sides of the CPU. And then I looked at the other pin I was working on. I don't have the right glasses on, so it's a little bit hard to say. And I was going down the pins to see if there was any short there. And sure enough, I don't know if you heard that, there's a short. And it's right here on this second pin. It's pin 2, which is data line 3. So that would definitely cause a problem. I don't know why it's connected to that. I looked at the schematic and I tested this on my Amiga 500 to see if that was the case. It is not. So somehow something got connected somewhere to data line 3 from this, just happens to be the one that I ran that bodge wire for. I don't know how I would have figured this out otherwise, and pretty much this was just a random check. Just to make sure those bodge wires weren't touching anything. So I need to go figure out why that's connected to this pin or how it's connected mechanically. I have no idea. And then that could be the root cause of why this thing isn't booting up. Because when the processor boots up, if it notices a conflict on the data lines or the address lines on the bus at all, it will go into halt mode. The processor will put itself into halt, and that's what I'm seeing. So boy, that would be great. If that was the problem and I could get this thing working, I would be so happy because I've spent 4 or 5 days now just troubleshooting the board and all the chips and everything. So I'm going to go see why that's connected, disconnect it if I can find the problem, which I will eventually. And then who knows, maybe it'll work. Well, guess who effed up, folks? Yeah, I think it was me. I think we have a 1D10T error here. So I was looking at this chip where I soldered on those bodge wires to go up to the Gary chip to replace these ones that were no good because of the battery corrosion. So I was looking at this chip on the schematic and I was just wondering, does D3, the one that was shorting out over here on the processor, does that go anywhere near this chip? And indeed it does. That goes to pin 11. And I was like, well, pin 11, that should be one over from where I soldered the wire on. And so I started counting 1, 2, 3, 4, etc. Well, there's 9 pins here, which makes this pin over here on this far edge, the 10th pin, and this one, the 11th pin. And for whatever reason, my brain just thought, oh, 8 on this side. Yep, that's 10 on this side. And I soldered that bodge wire to pin 11 instead of pin 10 like an idiot. I'm telling you, it's a 1D10T error here, folks. Oh man. So that means I spent 2 days essentially trying to troubleshoot chips, traces, all of this stuff. And it could all be down to this problem, which I caused myself. Man, that's disappointing. Okay. Let's move the bodge wire over and see what happens. I was just about to open up a forum post on one of the Amiga forums asking for help because I'm pretty much at the end of my rope with this thing. And boy, I'm glad I didn't now because I really would have looked bad at that point. People trying to help like, oh, did you check this pin? Did you check this other thing? Did you check this? You know? And the whole time it would have been down to me screwing up a bodge wire. That's embarrassing. That would have been really embarrassing. It already is embarrassing. But it happens, folks. Okay, with the bodge wires going to the right place, will it work? Here we go. Oh, that's new. That's new. That's new. Come on, baby. Oh, we're getting close. Oh, there it is. There it is. It's working. It's working, in the words of Anakin Skywalker.
It's working! It's working!
Oh, man, look at that. Look at that. It's a beautiful thing. Amiga version 1.3. Yes! Oh, after so many days. Okay, now, the next thing is to put the other Kickstart ROM in and see if for some reason it'll work here when it wouldn't work in the 500. Okay, so far so good. No. No. So this, oh, yes. For some reason, the ROM works on on the 2000 and it doesn't work on the 500, even though it says right on the thing that it works for the 5000/2000. And I keep speaking to, I'm not used to how long the Amiga, I don't know how long it usually takes to boot, so I just figure it's not booting. And then it like pops up onto the ROM screen. Okay, 3.1 works. That's good, because some of those cards that I want to test on this thing needs 3.1. So I've got a working 3.1. I don't have to burn a EEPROM for this yet. So that's good. All right. This is awesome.
The thrill of victory, thrill of victory, thrill of victory, thrill of victory, thrill of victory.
Well, can you believe it? I finally got the Amiga to boot, to kickstart. Now, I still haven't tested the floppy drive or either of the floppy drives, actually, the 5.25 inch or the 3.5 inch. Haven't tested any of those cards. That'll be coming up on a future episode, of course. But I'm so glad I was at least able to get to this point through perseverance and overcoming the fact that I was my own worst enemy in the case of those bodge wires anyway. There could have been other issues though. I guess I shouldn't be too hard on myself, because I did replace that socket, clean up all the corrosion. There could have been a number of other things that were going wrong. I cleaned up that corrosion, for example, on that chip memory mod that was in there. That could have caused problems. So I did a lot of, I like to look at it as I did a lot of pre-work, and then just had that one problem with the bodge wires that I caused. But so glad to see it running. Can't wait to see what this thing can do, especially with those cards installed. And I do have a lot of mods that I plan to put on this board. A SCSI mod, floppy drive, the ability to read floppy drives from a PC, read and write Amiga floppy drives from a PC. And I'm working on a special product that I'll be selling at the store to make that happen more easily. And of course, I have to check out and see if I can get HDMI output on this thing with the RGB to HDMI device that I sell on my website. So many of you have ordered it. I just went back and looked at the number of orders, and I cannot believe it myself. So many of you have ordered that device from me, thanks to all the development that's been put into that by E&B and others working on the project. And really, it's a community effort. So thank you if you're one of the people that have bought one of those. Some of that goes to support the project itself in the form of contributions to keep that development going. And some of the proceeds actually go back to me to help me run the channel and keep things going here. So it all works out in the end. Anyway, I hope you're looking forward to more Amiga fun. I can't wait to see if I can actually get Workbench running and play some games on this thing. And I think hopefully now the hard part is over. Should I say that? Am I going to jinx myself? I don't know. But anyway, I hope you're enjoying the series. And if you are, give a like to the video or consider subscribing. I don't say this often, but maybe click the bell icon so that when those future episodes do come out with all of those mods or games or future things that you want to see about this Amiga, that you'll actually be notified of that directly. And you can just click and enjoy the video without having to wait for it to show up in your feed. I also want to thank my patrons who have been so supportive, and I've got some new patrons now, and more I'm sure are on the way. So thank you in advance to everyone for your contributions and support on Patreon. Really appreciate it. I'm getting ready to do an after the episode commentary right now for my patrons, so that'll be exciting. But otherwise, thanks for watching, and we'll see you next time for more Amiga fun. Patrons receive ad-free and early access to content after the episode commentary, and of course, your name in the credits. If you liked that episode, here's a few more you might enjoy, and I thank you for your support.
End of line.